My name is Sarah Rockstad, and I'm a fifth-year graduate student studying pharmacology. And more specifically, I study dopamine transporter through mass spectrometry-based proteomics. So I feel like that quick little intro section was just full of jargony words that most people, including lots of scientists, won't even understand. So I really want to fix that. On a broad level, I study pharmacology, which, contrary to popular assumption, is not what you study in order to become a pharmacist at your local Walgreens. It's actually a field that tries to understand what happens when drugs enter your body. It's a very diverse field because this analysis can be applied at many different levels, starting at looking at effects of drugs on your entire body as a whole, down to the interactions of specific drugs at a tiny little protein level. So I focus on that last little bit by looking at how drugs affect and interact with a particular protein. Specifically, I study the dopamine transporter, which we call DAT. Lots of people have heard of dopamine. It's that little chemical that makes you happy. Without DAT, or when DAT function is blocked by drugs like cocaine and amphetamines, your dopamine levels will go way up, which makes you very happy, hence all of the people who use those drugs. But this can also have adverse effects on your brain. So I look at DAT and the other proteins it associates with and how those change along with drug treatments. And I do this by using mass spectrometry-based proteomics, which again is a mouthful. So you've probably heard of the genome and genomics, which look at all of the genes within an organism. So similarly, proteomics looks at all of the proteins, or a particular subset thereof, within an organism. So in order to look at all these proteins, we use mass spectrometry. Mass spectrometers are machines that can measure how much a particular molecule weighs. And with specific chromatographic techniques, we can separate out thousands of molecules within a complex protein mixture so that the mass spectrometers can distinctly measure the mass of individual components. These components are then searched against a database in order to identify the proteins that were in the particular mixture. So with my DAT samples, I compare the components of multiple samples with different treatments in order to see how things change. So hopefully after this little blurb, you have a better idea of what I mean when I say that I use mass spectrometry-based proteomics in order to study the pharmacology of the dopamine transporter.